Hello class, welcome to this course, Web Development using PHP. PHP meaning Hypertext Pre-Processing Pages. Here are the learning outcome of this week's lecture. At the end of this lecture, students should be able to explain client and server, the concept of client and server architecture, the differences between static and dynamic web pages, the history of PHP and its trend. Client-server architecture is a global model that is used or employed to describe the interaction between a client, which makes a request, and a server, which provides services to the request or which serves the client. So if you look at it, the right hand side of this page or this slide, you see this is an example of client-server architecture. So in this model, the client sending a request to the server. Here are the clients. The clients can be your personal computer, can be a desktop, can be a PC or a laptop, it can be a mobile phone, or it's any device that is connected to the internet. So this client provides service, make a request to the internet. So this request is handed over by the server. So the server processes the request and sends it back to the internet, while the internet distributes the required responses from the server down to the clients. Now, looking at the individual components, you see the client is the end user. This end user consists of the devices in which the user makes use of to make requests, while the server is the machine that processes the request and serves data or resources to the client. Well, this network, which is the internet, is the medium through which the clients communicate with the server. It can be the intranet, internet, it can be the LAN, any other forms of communication one chooses. So if you look at the entire pictorial representation, it depicts a client-server architecture. Now, let's now explain in deep the communication processes that happens between the client, the internet, as well as the server. Now, initially we know that the clients are made of the computer, the mobile devices one used to communicate through the internet down to the server being processed. So now, what is these clients? What do they do actually? Not just they communicate. The first thing they do is to initiate this request through HTTP, which is the Hypertext Transfer Protocol. It's mainly used for communication within web pages. So these requests are handled by the HTTP. For example, if you look at when one wants to browse from a Google Chrome or any form of browser, be it Mozilla Firefox, Internet Explorer, so at the address bar where you type in the address, you normally see that HTTP comes in first, meaning it's defining a protocol that particular browser will use in handling its request. Secondly, servers. These servers listen to this request and respond with the data, such as HTML pages, images, or file. Yeah, the server, since it's providing services to the clients, the response of the server is by providing the items or the resources required by the clients. Now, communication occurs through this protocol. You have TCP, Transfer Communication Protocol. It's the exchange communication between the two, which is the TCP and the what? HTTP. The HTTP handle the request from the web pages, while the Transfer Communication Protocol process the request from the server down to the client. Now, web browsing. Web browsing is a client request web page from a web server, which is example Google Chrome, Firefox. An email client requests email data from an email server. As you are sending mails, the requests you send in are treated from the email server. File sharing is simply the process where these files are shared or requests of files are handled from the file server. Now, let's understand what web pages are. A web page is a document that is accessible via the internet. It is typically developed or employed using or produced using HTML. HTML, which is another language of developing web page, is called hypertext markup language. And structure-wise, or the structure of a web page, one, it consists of the HTML, two, it consists of the CSS, and three, it consists of JavaScript. Let's now understand the meaning of each. HTML, it defines the structure of the web page. It shows the content, including such as heading, paragraphs, links, images, audio files, video files. All those things are being defined using the HTML language. So the CSS provides styling where we color the texts, the buttons, the text box, and so on and so forth within a web page. While the JavaScript handles the interaction, such as actions that happens within the web page, handling of requests. For example, when you click on a button, what happens? So it's the responsibility of JavaScript to handle such interaction between those web pages. So the next thing is on the structure of web page is browser rendering. So browsers read the HTML, CSS, and JavaScript of web page and render it for display. So rendering is just simply the process of getting the contents of the three interacting structures, HTML, CSS, and JavaScript, for display. So this page is parsed and constructed in the browser. And this browser consists of what we call a rendering engine. This rendering engine includes, for example, in Chrome, we have what we call Blink. So this Blink is a rendering engine that is used to render the content of a web page. So, and further example, we have the static content of a web page. When we say a content is static, it means the information on that particular page or content of that particular page is static. It remains constant. It does not change. It can be changed rather, but the content does not change, unlike other pages that the content is dynamic. So interactive content such as forms, sliders, dynamic content are dynamic content of the web page, where if you click, you supply information, and this information will be passed to the server side message. So the content is temporary, awaiting action. If immediately an action takes place, the content gets away and it goes back to its initial stage where it will receive new content. So now, let's now look at the forms of web pages in details. Static web pages. We say initially from the initial slide, we said that a static web page displays the same content to every user and does not change unless it's manually edited. So that was what I said. I said that content remains the same. An example of that static web page is About Us. Normally, About Us is normally a content of page that remains the same. About Us normally comes to, in most browsers, About Us just displays information about that particular organization or that particular page. So typically it's static and it has some certain characteristics. It is typically written in HTML and CSS. Normally, the texts are written in HTML. The content will be written there and they'll be styled in CSS. And we already know what a CSS is. It is a cascading style sheet that is used for development of layout, colorization or coloring documents, or to beautify a web page instead, to put it in a simpler form. So another characteristics of a static web page is it's simple and it is fast to load. Of course, since it is simple, it normally contains little media files. Normally, the pages contain certain images, at most videos with small size, like it's easier to load. So another thing is another characteristic. It's suitable for informational sites because for one, wanting to know about an organization, all you have to do is just swipe into the organization webpage to read more about the portfolio, about the documentation, the whereabouts of the organization. Now that we know about static web page, let's now know what a dynamic web pages are. So the dynamic web page changes content based on user interaction or data input. I've said this too in summary from initial slide where I said the content of dynamic web pages changes on actions of the users. So once users, for example, which I made an example, a form. Once a user fills in a form, on clicking on submit, an action takes place. And this action is being handled by the JavaScript. So immediately it's either the form, the content of those page are submitted to the server side, or if there are errors, another action will take place to indicate that that content changes. So it also has some characteristics. One, these contents are generated in real time by the web applications. And we already know the example, JavaScript. PHP is also another example, which is going to be the language we're going to be used throughout the lifetime of this course. Another example is it requires a back-end server and database for storage and retrieval. I've said that again. When you fill in a form, click on it, the content are submitted or transferred to a server side. That example is user profile, product listing, blogs, blah, blah, blah. Take example of your Facebook pages. Once you create a Facebook account, it's the Facebook site automatically creates a profile for you where you can personalize based on your choices. Right? Another example is product listing. If you go to a website where that deals with sales websites, where you can see the list of products, this is also another example because it changes with time. Similarly with blogs, people that write blogs, they write information, interesting stories about things, about people, events, about marketing, and so on and so forth. All these are examples of web pages. So now that we know about web pages, we know about the contents of web pages, we know about the different types of web pages, let's now introduce PHP. And we're going to introduce PHP by, we start discussing its history. What is the origin of PHP? Where does PHP come from? What happens? Let's now know. Now, let's start with the origin of PHP. PHP can be, we already know the meaning of the word PHP. PHP is an abbreviation which stands for Hypertext Preprocessor Pages. So it was created in 1994 by Rasmus Ledov. And initially it is a set of common gateway interface, CGI script, to track visitors. So that was how it started. It started as a gateway interface that is script that's used to track visitors. Now, let's now look at the evolution of PHP. You can't discuss history without evolution. Like our people said, use it chronologically. Like over time, what happens? How does it transform? So in 1995, PHP became more sophisticated, where it added more support for database interaction. And in 1998, another version of PHP was released. It's called PHP 3. It was widely known to support dynamic web page interaction or generation. In 2000, PHP 4 was also released, which introduced performance improvement, and it was made to be more robust features, where it introduced more content of interaction. In 2004, PHP 5 was released, where support for object-oriented programming was introduced. Concepts like inheritance, polymorphism were introduced into this at this stage, where object classes were also created as features in this particular year. So in 2015, PHP 7 was introduced, where a performance improvement was introduced, such as features like type declaration, where you declare where classes will be introduced in enormous or in extensive content. So now that we've seen, in summary, we've seen the origin and the evolution of PHP. Why do we even choose PHP in the first place? Why PHP? So the first reason of PHP is free. That's number one thing. It's free. One could just use it free of charge without cost implication. Two, it is an open source and it is widely supported. Why PHP is saying, why is it important? It's free, open source, and it's widely supported across platforms. Two, its integration with database. It's simpler and it can be easily be integrated. It can easily be integrated with other databases such as MySQL, SQL, and so on and so forth. Another advantage of PHP is it has large ecosystem of frameworks. So, for example, we have Laravel, we have Symfony, all these things, and so on and so forth are ecosystems that support PHP. So, now that we understand the origin, the evolution, and the importance of PHP, let's now look at history of MySQL because it is another it is another database that blend in well with PHP, and we're also going to learn about it in this course. So let's now look at the history of MySQL. So MySQL, meaning my structure query language, was built or created by Michael Monty Wedinos in 1995. This particular structure database language became popular due to its speed, reliability, and ease of use. One thing you can give MySQL is it is easier to use. It has language. The language used is closely related to English language. It's easily known and it has simpler interaction, and one can learn it easily. So it was acquired by Sun Microsystems in 2008 and later by Oracle Corporation. Now, we've seen the history. Now, why MySQL? Like, why is it important? It's open source nature because MySQL and PHP are free and they make them popular choice for web developers. Since it's free, it is only common for it to become popular because since it is free, it has no cost implication. People can easily use it at any point in time with ease, convenience. Another thing is integration. It provides a robust relational database systems. And PHP has built-in functions that interact with MySQL databases. Scalability and performance is also another importance because PHP and MySQL works together and they offer scalable solutions for building dynamic data-driven websites. So common uses of PHP or applications include e-commerce. PHP has been used to develop plethora of websites, thousands of them, that includes products, user information, and it's also used to create blogs and so on and so forth. Okay, at this point we've discussed about MySQL. However, there are other alternatives that can be used as MySQL. And one of these alternatives is MariaDB, meaning Myriad database. What is Myriad database? Myriad database is a fork of MySQL created by the original developers of MySQL, primarily Michael Monty Waldenius. So the essence of this design is to be fully compatible with MySQL, but with more often development and community involvement. So what this is saying is there are features that allow MariaDB to be interacted or to be generally used across different platforms. So the key difference between MariaDB and MySQL is one, licensing. MariaDB is licensed under the GPL v2, ensuring it remains open source. So MariaDB remains open source across all platforms. Another thing is the performance improvement. MariaDB often outperforms MySQL in certain scenarios due to its optimization. So when you have two softwares and one has better optimization, it's best you pick the one with the higher higher optimization percentage or accuracy. So additional features of MariaDB includes features like the area storage engine, better indexing, and JSON support, which supports Java open pages. So these are some of the key differences of we have MariaDB and MySQL. So why is Maria even DB important? Since we have MySQL, why is it important? So if you're looking for a free open source database solution with robust features and high performance, that's when you consider MariaDB. And it's fully compatible with even MySQL itself. So if a code is written in MySQL, it can be easily or seamlessly be migrated to MySQL. Like I said, it can be generally be integrated across different platforms. Now we've discussed about web pages. We've discussed about different types of web pages and so on and so forth. Now let's even understand what is a web server. A web server handles HTTP requests and serves static content such as HTML, images, videos, audios, etc. An example of a web page is Apache HTTP server. So the most widely used web server known for its flexibility. we have this Nix, which is known for its speed and ability to handle higher traffic. So you can see the Apache is widely used because it is flexible, while the Nix, it has speed and it handles higher traffic. In case of traffic on the web, so you use a Nix. So now, since we know what a web server is, let's now look at an application server. An application server processes dynamic content and handles business logic. So it can serve applications built with Java, PHP, Python, etc. So you can see web servers generally handle HTTP requests, while an application server is a form of a server that processes dynamic content, web content. So examples include Tomcat, a Java-based platform server, a Java-based application server primarily used for running Java servlets and JSP, Java Server Pages. We have a Pyra, a modern Java application server compatible with Java EE, offering clustering scalability and cloud deployment features. So all these are things you can also read further on to improve your knowledge. However, these are the basic means, and I think it will help. So now, let's now look at the next slide. So at this point, we want to see the difference between a web and application server. In fact, from the previous slide, I've even mentioned some of them already. The web server serve static content, while application server generate dynamic content. We already know what is static content, where the content remains the same all through, while dynamic content, where the content changes. While the web servers interact directly with clients, whereas application server run business logic and manage database connections. So you can see web servers serve the clients directly, while the application servers run business logic and manage database connections. So this is easier to comprehend. So how do you know the right server? So choosing a web server like Apache for static content, application server like Tomcat for Java applications. This is just a more or less an example. Consider Pyra or Tomcat for Java EE application needing enterprise level feature. So it's to choose the right server depends on your needs. What exactly do you want to do, or what are the achievements you have, you intend to gain? So these are your guide. If you know that the page you're going to develop is static, you go for Apache. If it's going to be a dynamic, you go for Tomcat. But if it's going to be an enterprise-based application level, you either consider Pyra or Tomcat. This is what choosing the right server case is talking about. So this brings us to the end of this lecture class. However, I have some quizzes for you. Try to see how you can make attempts to these particular questions. At this point, wish you best of luck. See you in the next class. Bye-bye.